Hi everyone. So we are gonna today once again start our word2vector word embedding and sentiment analysis. All right. So in a previous live video we had already done our word2vector word embedding with a spaCy, and we understood it how we need to do this word2 embedding. And if you don't remember it, what I can do here, I am going to share a link to this notebook so that you can follow along with this notebook. All right. So I'm just gonna paste it here. Let me paste it here. All right. So in a comment, I have given the link to this notebook, and now you can follow along with this lesson. So the thing which we are going to do here, it is word2vector word embedding, and in this we are going to do a sentiment analysis, and we have taken a data set of just a second, let me fix it. In this I have taken the data set of IMDb movie reviews data set. All right, superb. All right, now I'm assuming that you are connected, and let's go ahead, connect this notebook. Thereafter I'm gonna run it. So here we need to first install a large model of spaCy. All right, let's go ahead. All right, let's go ahead, run it. All right. Okay, so this is word2vector. If you don't know, about the word2vector, in a previous live lesson, I have talked about word2vector representation, that is NLP tutorial number 18. So you can visit at kgptalkie.com sorry, and then you can watch it there. All right, so while it is installing here spaCy and large model of a spaCy, in meantime this is a raw data link. All right, so this is the raw data link, and in this data link we had a text data. Let me open it and show it to you. It has their text data, which was a sentiment data. It's loading. All right, so it's taking a little time. So there we have a label and reviews. So these reviews are text data, and there is label which says that whether this one is a positive sentiment or a negative sentiment. All right, so these things we have already done. So I'm just gonna walk through all those things. Not an issue. While it is installing, it is taking just a little time. All right, so this large model is 900 megabyte large. That is why it is taking a little time to install a spaCy large model. All right, superb. And once again, I'm telling you that there is another lecture in which I have talked about the introduction of word2vector word embedding, and you can watch it there. Tutorial number 18, NLP tutorial 18. All right, so it's almost done. It's just taking some time. Once it is done, then I'll be explaining you these things, model building and other things. This should be done by now. All right, so not sure why it is taking time. This should have been done by now. Anyway, all right, so in meantime, while it is installing this spaCy large model, let me explain these things. So in this line, I'm importing here a spaCy. All right, and thereafter I'm importing a large model of spaCy in this Google Colab notebook, and then I have loaded it into an NLP object there. And thereafter I was talking about here king, man and woman. All right, so how these are similar. So you see there a king is there and its gender is male and man is also male gender. So there is high similarity and correlation between man and king. And there you have here woman, which is a feminine gender, and there is king, which belongs to king belongs to their male. All right, there is a female. So what happened here? The king and man is much more similar than king and woman. All right, and that I was showing here that how you can get the similarity. So in this similarity, you get king and man are around 40% similar, 0.4. That's the similarity coefficient. But if you see there king and woman, so for a king and woman, the similarity is pretty much less. That is just 0.26. All right, so this is the way how we get the similarity matrix, and the similarity matrix we get by getting the similarity between the vector representation of the words. All right, thereafter a model building. So it's just we did previously till cleaning. All right, in tutorial number 18 we did it till cleaning. Thereafter I'll be showing you how you can build your model and then you can train it. All right, so the model building was being done with the first of all, of course, we need to import here necessary Python packages, and those necessary Python packages are like NumPy as NP, Pandas as a PD, sklearn.linear model, import logistic regression. So we'll be using here a logistic regression for our machine learning model building. Train test split will be used here to split our dataset into a training dataset and a testing dataset. And then we are having here a classification report. So in this classification report, we will be evaluating our model, how good our model is. Let's go ahead and run it. Thereafter, this link I have already shown you on the GitHub. It is available at my GitHub repository. There, let me make it all CSV ML data files. All right, so that's the this is the repository name. All right, where this file is available. Otherwise, you can get it from this link directly. All right, so let's go ahead. So with this line of code pd.read CSV, we are reading our the data set directly from the internet in this movie reviews.tsv. All right, thereafter here there is head. So head is showing us first few line of this data. The first few lines are these 5 rows. Thereafter, we are installing here pre-process package from KGP Talkie. Let's go ahead and run it. All right, then we have here get clean. So this get clean, what this get clean is doing here, this get clean is actually doing here pre-processing of the text data. So what are the pre-processing which we are doing here? Those are like conversion in lowercase and replacement of backward slash with nothing and replacement of underscore with a space. Thereafter, we are having here a contraction to the expansion method. Like we have a contracted words that will be expanded into a general English word. And then we have here remove emails, URLs, HTML tag, retweets, etc. These will be removed from the text data. Thereafter, accented character and special character, etc. will be removed once we call this get clean. Thereafter, there is pre-processing. We are importing it, and then here you get it like you have text data with all right, text data like this, something like this. All right, so it was like this. Now after doing a pre-processing, we have got this result. All right, super. So till now we have already done. Now I'm going to show you how you can build a model so that we can train it. All right, superb. So the first of all, we have to do a pre-processing in our data set. So this is data set and we have to do a pre-processing for this review column. So let's go ahead and use here a lambda function to do this pre-processing. We have here a df, and then we have here reviews. All right, do we have review? Yes, so there is review. Let's go ahead and copy it here. So I'm gonna use here a lambda function. So how do you use this lambda function? In this lambda function, you use apply method, thereafter this lambda x. So in x, you get the text data of each row one by one, and then I'm calling here get clean and then passing this text data in get clean. Then the data will be cleaned and then returned back to our review column. Let's go ahead and run it. It might take a little time to complete its processing. In while its processing is done here, now our text data is clean. Currently we are having here a clean text data. All right, so this one is clean. We don't have any special characters, underscore, or like those anything. Superb. Now let's go ahead and build our model. All right, so this is the model building, and then I'm gonna say here word2vec conversion. All right, so so this is word to vector conversion, and how we are going to do it. All right, so Bharat is asking about how it is different from BERT. Yes, the word to vector is completely different. The first of all, BERT is based on the transformers. All right, and BERT includes there a conversion of text data into tokens and then classification. But here word to vectors are only text to vector conversion. It don't do any machine learning task here. And apart from that, BERT model is much more accurate than the other models. But BERT model is not suitable for production because it's a huge size and it's pretty much slow. So you will not find that anywhere BERT is being used as a production. For your research in NLP field, definitely you can use BERT, ExcelNet, or RoBERT and DistilBERT, etc. So those are pretty much advanced model in NLP, but those are not being used in a production because their model size is huge and they are slow. But still, it is good to learn those things and you can continue your NLP research with those models. All right, perfect. Now let's go ahead and the first convert our the text data into a vector. If you remember, we have already imported our NLP object in which we had loaded a large English model. All right, so the NLP we already have. Let's go ahead and see here text data, which is just simple like cat and dog text data. Thereafter, I'm getting here a doc object, and then there you have NLPX. So this doc object is having a tokenized version of the text data, and in each token there is a vector. All right, so how you can do those vector? You can simply type there doc dot vectors. All right, so this is a vector there, and by default the vector size is 300. So the shape of this vector is 300, and you can check that shape like this. All right, so the shape of this vector is here 300, and when I say doc dot vector, that's mean I'm applying a vector to this whole object. Whole object is this cat and dog. All right, that's mean it is getting a vector for this whole object. But if you want to get an individual vector, then you can definitely get those individual vectors as well. For example, let me add few more code cells, then I'll show you it in very detail. Like let's say you have here doc dot the tokens. So these tokens it's actually the doc. Let me show you it. You can get it with the help to that should be, I think, doc dot token. Is it dot doc token? No, it's not that token. All right, let me get that. Just a second. So you type there help, and then if you are not sure about any function, then you can definitely get there a help. All right, so we should get there. Just a second. All right. Okay, so it's not available. Let me get it here. All right, so you have here a spaCy tokenizer. All right, I'm just missing that part there. So whenever you get any problem while following the Leech lessons, you can get the get the details from spaCy.io. Just a second, it was somewhere here. Do we get here? All right, I think, yeah, so the doc I can directly iterate over the doc. So that was the thing I was missing there. All right, so there, once you have this doc, all right, you don't need to get that token. All right, so once you have this doc, so in this doc we have here cat and dog. So these are the tokens, and with the 0 we get there just a cat, and you can directly get there vectors. All right, doc.0. So this vector, all right, now this vector is for a cat. All right, and if you put there 1, then you will get a vector for a dog. For example, if you notice, just let's say this first starting line, which is minus 0.15, and now we are gonna get it for a dog, you will get there a different vector. All right, do you notice here? This is a different vector. But if you don't put anything there, you will get a vector which is actually a full vector for a whole sentence. All right, perfect, super. Now let's go ahead and write a method here. All right, so the method which I'm gonna all right, so Abhishek is asking about vector shape is different for special characters. No, vector shape are not different. Vector shape are same for all those characters, and for all the sentences are the tokens. Special characters are also token, and the vector size for those are either 300, and if any word are out of vector, that's mean if vector is not present for that particular of word, then there will be a 0 vector. All right, let's go ahead and write a function here, a method to get a vector. So I'm going to say here get underscore vec. There is x. All right, then we have doc is equal to NLP and x. Thereafter, I'm going to get here a vec, that's the vector, is equal to doc dot vector. All right, thereafter I'm going to return it here. So the method is done here. All right, this get vec, now we have x here. All right, so this vec, this x, and if you want to get the vector directly, you can just type there get vec and x, you will get this whole vector. And do remember, the shape of this vector is, how much shape of this vector is? This is a 300 shape. All right, just a second, let me get the water. All right, okay, so we have written a method to get the vector. Now let's go ahead and calculate a vector for all the rows of our data frame. So for all the rows of our data frame, what are those rows which we are talking about? if you type there df.head, so these are the rows. Now we are gonna get here a vector for each of these rows. All right, so once again we are gonna apply here a lambda function. So there we have a review dot apply and then a lambda x, and there I'm going to simply type there get vector. All right, get vec x, then it will calculate a vector for each row, and the vector for each row will be placed at each row in this df vector column. All right, perfect. Once we get that, I'll show you. It might take a time because there are a large number of sample, and to calculate a vector representation for those samples it will take some time. All right, so while it is doing, let's go ahead and all right, so we can do like df.head. all right, while without completing this cell we won't be able to execute this cell, so we have to wait it. This is always a problem in live class. Whenever you take a large data set, then you will always have to wait to complete its training. And I just want to ask you guys, if you are watching it there, and what do you do when your machine learning model train? All right, reply it. All right, so it's a simple question. What do you do, all right, when your model is being trained? All right, so this is a huge question for all the data scientists, and every time we get stuck there when our model is being the executed are being trained. So depending on the shape of the data and speed, it will definitely take some time. I'm not sure how much lines were there. Yes, some tasks can be definitely done faster with using a task, because it utilizes the parallel processing. So the maximum you can get the speed, which is equivalent to the just number of times you have the cores in your computer. For example, if we have, let's say, a quad core computer which is having a 4 core in your computer, and a traditional pandas data frame uses only one core or a single core, and the rest of other 3 cores are not being used in the processing. But if you use their task, then definitely you can utilize other 3 cores which are sitting idle, and then those core will calculate this do the processing in a faster way. But those are not always recommended, because sometimes because what happens sometimes a current input is dependent on the output of a previous pipeline. That means, for example, let's say if you have some task like this one and this one, in that it doesn't matter how many cores you have to get the output of this cell before we execute this one. All right, so in parallel pre-processing, a task can be useful, but not all the time. All right, so it is done. It took, I think, around 5 to 6 minutes. Let's go ahead and see this data frame. So what do you see there? You see there vector representation is calculated for each row, and it is now placed in a new column, which is a vector column. All right, perfect. Now what I'm going to do here, I'm going to prepare this data for a further pre-processing so that we can feed it into our machine learning model. So the first of all, we have to convert it into a NumPy array. So x is equal to df.vec.to underscore NumPy. All right, and then x is equal to x dot reshape. There we have a -1 and 1. -1 says that adjust in as many as rows you want, but put it in just a single column. All right, once you get it there, thereafter let's go ahead and check the shape of this X. So the shape of this X is very weird because we know that the shape of these lists are 300 and we should have got here a 300, but still we are getting here a 1. So what's the problem here? If you check this data X, it is not properly actually formatted. All right, that's mean it is not properly reshaped. So we have to work on reshape. All right, where is that one? Just a second. Yes, so it's here. All right, so it's huge data, and we have to reshape it properly, because if you notice here, it is array of array. So there is array and then there is another array. That's mean there is two array, and these array is in concatenation. That's mean we have to do here a numpy concatenation. So let's go ahead and do that numpy concatenation. You can do here numpy dot concatenate, thereafter numpy dot concatenate. All right, so we are going to do here for first array concatenation on axis is equal to 0. Thereafter, once we get the result for this concatenation, then that will be again concatenated for this one. All right, so there, once you get it, thereafter we are gonna reshape it again with -1 and 300. Now we should be able to get here a correct shape of our data frame. So there you have got x.shape. So it says that there are 2000 lines are available for our data, and each data is having a 300 dimension. All right, that's mean we have converted our text data into a vector representation. Superb. Now our data set is ready here, which is X. Thereafter, let's go ahead and create here Y, which is a target output or a target variable. A target variable, we are interested here in a sentiment. All right, so that's the Y there. All right, so I think, is it sentiments or sentiment? All right, so that is not, oh sorry, this is a label. All right, so the label is sentiment. All right, so that's the label there. Super, we have got our X and Y. Now we are going to do here a train test split. So let's go ahead and write there train underscore test split. We are going to pass here X and Y. Thereafter, we are going to pass here a test size. So this test size I'm going to pass here 0.2. That's mean the 20% of the data will be used in training, in a testing, 20%. All right, random state is equal to 0. Thereafter, I'm going to say here a stratify is equal to Y. So stratify will make sure that we get here, training and testing set division for a target variable in with respect to this test size. All right, that's mean a 20% of the positive and 20% of the negative should be placed in a testing data set. All right, thereafter we are gonna get here X train and then X test, and similarly we are gonna get here Y train and then Y test. So we have got here training and testing set. Thereafter X train dot shape, and then we have got here X underscore test dot shape. So there we have got a 1600 data sample for a training and 400 data sample for a testing. All right, so we have got here training and a testing set. Let's go ahead and train our model. Of course, we have not built our model yet. All right. So we have to, of course, first build our model. Let's go ahead and create a classifier here. CLF is equal to logistic regression. In the logistic regression, by default solver is not set, so we have to set it here. I'm going to set here a live linear, and if you are interested to know more about a solver, you can these are the input here parameter which we pass there, and in these input parameters we have here a solver. By default this LBFGS, but in coming versions of logistic regression it will be removed, so it is always recommended to use a solver. All right, perfect. Let's go ahead and run it. So our classifier is created here. Then we have here a clf.fit. Thereafter we have x underscore train, and then we have here y underscore train. Let's go ahead and run it. Now when you run it, it takes just a while. All right, it's pretty much fast, and it's very fast. So training is done there, and then I'm gonna do here ypred is equal to clf dot predict. All right, x underscore test. So there we have got here a predicted values in ypred, and then we can do here a classification report. So print classification report and then y underscore test, then y underscore pred. So training and true values of y and predicted values of y are pass here. Just a second. Why this? Okay. So there is error. All right. Yes, Kharvari. Thank you. Yes, thanks a lot. All right. So there, what you get here, you get a 77% of accuracy for this just a small data set, which has here a 2000 data points. If you remember in some of my previous live classes, I think it was tutorial number 17. All right, in tutorial number 17, I have talked about how you can improve these accuracy by tuning the hyperparameters. So I have shown there how you can tune the hyperparameters, and those hyperparameters are like a solver, all right, like a class weight. And if you put the class weight as a balanced, then it will be calculated in a balanced format. Thereafter with value of a c and with the penalty and with the solver. So with all those things you can optimize it. All right, so go ahead and watch their tutorial number 17, perhaps that one, where I have talked about the optimization. So this is how you can do it. All right, and this is somewhere generally where we stop our videos, but there are a lot more things which we can do apart from this. For example, you have trained your model, then what to do next? The next which we are going to do here, we are going to save this model so that we can use this model for so that we can use it for our later on for our other purposes. All right, so let's go ahead. First of all, save this model. So I can simply save this model, type there import pickle. So this pickle will will save this model. Let's go ahead, add few code cell here. So to save it, you need to type there a pickle dot dump. All right, so this dump will save this model, which is a clf, and then I'm gonna pass here a file path where I want to save it, and I'm gonna say here word2vec sentiment dot pkl. All right, and then I'm gonna load it here with the right binary mode. Sorry, I'm gonna write it into a binary mode. Let's go ahead and run it. Now simply you will notice here that this model is saved, but this model is saved in online, so you can download it from there. All right, so just click on there, it is downloaded in your local computer. All right, perfect. Now once it is loaded in your local computer, then what to do next? All right, so you can use it, you can reload it again, and thereafter you can do testing on this, and then now I'm going to show you how you can reload it. All right, just a second. All right, so here our model is there, word2vec sentiment.pkl, which we had just downloaded. All right, and for that purpose, what I'm going to do here, I'm going to open my Anaconda. All right, so I'm gonna open my Anaconda and then run it into administrator mode. All right, so it is running in administrator mode. Thereafter I have to come back here. All right, otherwise what you can do here, you can create here a new folder like sentiment. All right, and then I'm gonna place it inside this sentiment, and then I'm gonna create here a new model, and a new folder. In that I'm gonna say here a model, and then I'm gonna place it inside that one. All right, now I'm gonna navigate inside this sentiment, so cd. All right, now we are inside the sentiment. Then I'm gonna do here a Jupyter notebook. All right, superb. Now we are inside here. We are already done here. Let me show it here. We are already done with our model training. Now I'm going to show you how you can test it offline. The offline, that's when we are testing it here in our local computer, and the model which is stored at our local computer. All right, so you have to create here a new Python file in your notebook. Now it depends on you whether you want to create it in a Jupyter notebook or in a Python file. So I'm going to say here the testing sentiment model. All right, so testing this sentiment model. Now the one thing you should always remember it, I think, am I able to show you this the notebook? I'm not sure whether it is visible to you. Can you tell me that? Are you able to see this notebook? All right, I think some empty screen is coming. I think empty screen. Please tell me that if you are able to see this screen on which I'm talking about the sentiment model prediction. No? Okay, so you are not able to see that one. I'm not sure how it has happened. Just okay. I did not haven't done anything, but not sure how this is happening. All right, now you should be able to see. Can you see it now? All right, I think it is visible to everybody. All right, so this screen is now again came back online. All right, so I did here what I did. If you could not follow this video. All right, so the thing which I did here, that's the administrator. I opened my Anaconda in administrator mode. Thereafter, I navigated to this folder, which is inside this user KGP Talkie, download sentiment Jupyter notebook. So I started it. All right. So after starting this Jupyter notebook, I created here a new notebook file. Thereafter, I have just written there the testing sentiment model. All right. Perfect. So now what I'm going to do here, Mr. Rao is asking about what is NLP. NLP is natural language processing. In computer science, we generally deal with the text data in the NLP. All right, so the Mr. BK Misra is asking about, can you help me my PhD work, word sense disambiguation? Well, so if it is a PhD work, then definitely it is gonna be, the pretty much hard problem. And anyway, so if you have any specific question regarding your thesis work or any of your project, you can definitely ask. Otherwise, you can write me at my the email Udemy or info@kgptalkie. All right. So I would definitely try to answer your queries. All right. So write me at udemy@kgptalkie.com. All right. Let's go ahead and come back to the testing sentiment model. How we can do. You have to always remember one thing. Whatever pre-processing you have applied, you have to apply a same type of the pre-processing in your the prediction model. All right. So what are those pre-processing which I had applied there? Those pre-processings are this one: get clean and get vector and those things. So the first of all, you have to get it here, this get clean, and for that we have to import here preprocess KGP Talkie. All right. So there we have preprocess underscore KGP Talkie as PS. It's actually the pre-process. So this is, so all right, so this pre-process KGP Talkie, and thereafter RE. All right, so import RE. Thereafter a few more things I have to do here. The first one is import spaCy. Thereafter you have to get your vector method, because we have to convert our text data in the form of vector to get the prediction. All right, so that's the vector here, this one. All right, so this vector representation, you have to copy it here. All right, superb. And before copying that one, we have to do a few more things here to make sure that it works as intended. And that one is building our this one, actually this part. All right, so these are the pre-processing you have to always do. Let's go ahead and run it. So what will happen here, it will get their NLP object. Thereafter we will get here a vector, and once we get the vector, then we will clean our data. All right, perfect. So I'm going to say here, all right, x is equal to, I'm going to say here, this was really a good movie. All right, so this is x, and in this x, what are the things which we have to do here? We have to do pre-processing and vector. All right, so x is equal to get underscore clean. All right, so get clean, and then there we have got x after cleaning. If you even put some here special characters, you will always get here a clean version of the text data. Thereafter we are going to get here a vector. So that we are gonna get it from get vec, and there is x, and there you have got here a vector. All right, so this is a vector, and this vector we have to pass in our model. All right, and now we have to load our model. So how we can load our model? It's pretty much simple. We can do here a import pickle once again. Thereafter I can say here a model is equal to a model or CLF, whatever you say there, pickle dot load. All right, thereafter you have to pass here, sorry, that should be open, and you have to pass the model address. So it's a model, and then we have here this one. All right, so it's all right. So we have got here our model, and one more thing, we have to read it into a binary mode. All right, so and it says that no module named sklearn dot linear model underscore logistic. So what happened here? I think it has broken out here. All right, so let me see it here. Why this? So this is broken. All right, so this one is broken in scikit-learn. This should not have done, because these things are imported automatically inside. Let's go ahead and download it. It's working there, but not sure why it is not working here. All right, let me see it here. All right, one more thing what we can do here for the testing purpose, we can test it here whether it is loading here or not. So what could happen here? It might have not downloaded properly or written properly here. So in a right binary mode, pickle.dump, that was done right and correctly without any problem, and it should work there. Just a sec. We can actually follow the same thing which we did there. All right. All right, let's go ahead and do this one. Okay, so that is not there. It's directly here. All right, in our root folder. Model is equal to pickle.load. So it seems here it is working here, but on my local computer it seems that the scikit-learn model is not supported there. Perhaps that could be the reason. All right, so it says that they are import sklearn. So version is here 0.213. All right, sklearn. All right, so there we have a model, sklearn model, that's the 0.22, and on my local computer 0.213. So that is why it is happening, and I cannot upgrade this sklearn at my local computer because I have few of my other models which only supports the 0.21 and 3. That's mean this model. So I would not upgrade it here. But if you don't have any, the compatibility problem, you can definitely upgrade your sklearn model to this one. Then definitely it will work. So in meantime, I'm going to test that same thing here in the online. For example, you have got your model there, and the same process you can follow along here as well. All right. So you have got their model. Thereafter, it's pretty much simple. You have to just, test it here like a model, and then you can do the prediction. All right, that's mean there is model. Sorry, it's one more thing I think I have to do here. I have to get this vector representation. All right, let's go ahead and copy this whole thing here. All right, so we have already got the model, and here we have got vector. Thereafter I'm going to say here a model dot predict, and then I'm passing here a vector. So you might get an the error there. So the error, what's the error is happening, we have to reshape our data in the form of -1 to 1. All right, perfect. Let's go ahead and reshape it and then run it. I think this should happen perhaps like this one. All right, superb. So what it happened here, I reshaped this data. All right, I reshaped this data in the just one rows and 300 columns. Like this is a row vector. All right, that is how it is predicting here, and it says that this is a positive sentiment. And which one is a positive sentiment? This X is a positive sentiment. All right. All right, so VK Misra explain import pickle. Pickle is a library there, and pickle do a pickling of, you can say pickling means saving of any Python objects, and we use pickle to save our models and the data without disturbing its encoding. All right, so and Mr. Rao is asking about, can we use here a player PyTorch model? I'm not sure about the PyTorch. I haven't used PyTorch. All right, so I'm not sure about it. All right, superb. So this is how you can implement your sentiment analysis model, and we have successfully built our sentiment analysis model. We have stored it, and then we after restoring it, then we reloaded it again and then predicted it and tested it carefully. All right, superb. So this is all about in this lesson, and thanks a lot for watching these. And if you want more videos, and then I request you to like this video and subscribe this channel so that you can get updates